Welcome to today's webinar in the Knowledge Mile series, part of the Lord Mayor's lectures on behalf of Alderman Professor Michael Mainelli, whose theme for his mayoral year is Connect to Prosper. In this free online lecture series, we address the connections in and around the square mile, what Michael likes to call the world's coffee house, and how these might help us to tackle future global challenges. I'm Professor Tim Connell, an Emeritus Professor at what is now City St George's, University of London. I'm also Chairman of the Gresham Society and a Fellow of Gresham College here in the City of London, and a liveryman of the Stationers' Company. I'll be convening this session and moderating the questions and answers afterwards. This is the plan for today: quick introduction for myself, the keynote presentation, and then questions and answers for about 20 minutes, so do please send yours in. Today we have a very interesting topic, and may I say that part of the Lord Mayor's plan for his year has been to draw on the livery companies of the City of London, and today's webinar is sponsored by the glass sellers. And it's interesting to note in the City of London we also have a company for the glaziers, but the glass sellers probably don't mention that. Glass today is the world's most important material, and if you read the items online, you'll have noticed that we have a quiz today. What is the most important thing about glass in the world? And I can duly report that there are 1.25 million kilometres of undersea glass fibre cable around the world. And if we didn't have that, we wouldn't have today's webinar. So I hope you all spotted that one. So I'm delighted to welcome today Mark Holford, Richard Katz and David Dalton, who represent a wide spectrum of organisations related to the glass industry and its many facets. So there's so much to say about you, gents, that I will leave it to yourselves to introduce, and over to you now.
Over to you, Dave.
Okay, good. Thank you. Good morning, everyone. As it says there, my name is Dave Dalton. I, for my sins, am the Chief Executive Officer of the British Glass Manufacturers Confederation, to give it its full title. We are the body that represents glass manufacturers across the UK and their supply chain. Moreover, we are a research institute under the subsidiary of Glass Technology Services, which is my origins as a scientist, a chemist and glass technologist of many years, 44 years in the industry. And I have spent most of my life in research. I'm a great believer and advocate of glass, and I hope over the next 20 minutes or so you'll get the feeling of the sort of passion I have for the material, and hence trying to answer the question, glass, the most important material. I think I will come on to a slightly sciencey bit that explores whether we're a material or not in a couple of slides. But could we have the next slide, please? So first, what I'm going to cover, a little history, and then a little bit about the nature of glass, tiny bit of science, nothing too heavy, promise. Then a look more interestingly into the future. Some of the things that we already do, but people don't necessarily perceive. And then finally, an attempt to stare into the crystal or glass ball and have a look what the future holds for glass as a material. Next slide, please. So I did promise a little bit of science and not to be too pedantic. The question is around glass as the world's most important material. But as a scientist, I must qualify at this stage that glass itself is a material state, not a material. In effect, what that means is many things can be qualified as glass. I think today, ostensibly, we're going to be talking about what people generally perceive to be glass, the drinking glasses, the bottles, the jars, the windows, automotive glazing, facades, all of those sorts of things, and the practical and scientific uses of glass. But fundamentally, just for everyone's knowledge, material state actually means that if you can stop any material cooling from a liquid state into a solid state and forming a crystalline matrix, which the vast majority of materials in the world are crystalline materials, if you can cause an aberration in that process, that means that as the liquid solidifies, crystals are not allowed to form, you create what is the glassy state. And many things can fall into the category of the glassy state. So the sort of subtitle of my presentation today is around the infinite palette that glass presents to society. So that's the sciencey bit done. I'll go on to a little bit of a mathematical bit just as a quiz as we move on. So could we have the next slide, please? So as promised, well, where did it all start? Well, glass is a natural product in many respects. The first instances of glass we have are those caused by things like lightning strikes on beaches, where an intense amount of energy is focused on a material that, cooling from a liquid state, can form a glass, and silica is the most common one. Most glasses that we deal with in a regular day basis, things like window glass and drinking glasses, bottles and jars, are made of something called soda lime silica glass. The important bit being silica. Silica is silicon dioxide, basically sand, and if you warm that up to a high enough temperature and cool it in the right way, you form a glassy material, which is this sort of frozen in liquid that has no long-term structure or order to it. And that's the key thing about glass. It's the ability to accommodate a vast range of things in an infinitely variable matrix. But that starts with nature. So the first things we see, can we have the next slide, please? Are peculiar glassy type objects you might find on the beach or in the hills somewhere, where lightning strikes a bed of material containing a high level of silicate, and you get in nature a vast range of natural glasses, typically things like obsidian, which you can find all sorts of wonderful examples in different colours, very sort of brilliant material. Things like snowflake obsidian is a white material with or black material with white flakes in it. You can have white or colourless materials. Depends on the nature of other elements that are around in the silicate that will actually colour the material. But in nature, we see all sorts of natural glasses. And this is just one example of something you might find while strolling along the beach or in the countryside where there's been an appropriate site. And there are many examples in museums that have been cut and polished into beads and ornaments. It's a fabulous natural material. Next slide, please. So just to cover some of the things that we find by man-made glasses, the things where you currently expect to see glass and understand it to be glass, and then moving on to slightly less obvious places, and then some places that you probably wouldn't even imagine contain glass. So I guess the most obvious places, and some of the things I've already mentioned, bottles and jars. Glass is a great material in terms of its contact with food and beverages, and therefore we don't get any tainting of that. So for hundreds of years, we've used glass as a containment material for food and beverages, and it plays a very important role even today in that environment. I guess one adage that people use quite a lot is glass is something we tend to look through, not at. A classic example of that is windows. We have windows to allow visibility of the natural environment outside where we domicile. Windows are designed to be looked through, not at. But in the extreme, we've cast our mind into things like decorative glasses in churches, stained glass windows. There is this attempt to look at rather than just through glass in its flat form in windows. So it isn't just looked through, it is designed to be looked at. I think all of us remember school days, even if we didn't continue to do science subjects, so laboratory wear, optical devices, even spectacles. And some of the most important things in glass that shape our history are things like telescopes and microscopes. It is believed that the different rise and fall of civilizations that bring us towards where we stand today in society was very much premised by the change in the fortunes of Eastern and Western societies by the introduction of the telescope. Before the telescope, Eastern societies were the most advanced in the world. After the telescope, when we could see beyond the normal shot of eye, when we could look to the planets, when we were in battles and we had the ability to see what the opponent was doing in advance. That gave us the edge, and that shaped the balance of the world. Microscopes in science and technology helped us see beyond that the human eye could, and understand beyond the natural world things that we could influence and change in that world. Simple things like camera lenses, which we're all used to, now ostensibly in our phones. But that brings us on to the subject of phones and technology that we use now on a daily basis, all dependent on glass, not just in terms of the screen, the touch screen, but also in terms of the circuitry in there, the beam splitters, the things that actually carry the optoelectronics that make the device work. And as Mark said at the outset, things where without that level of capability, communications as we know them today wouldn't be possible. But then some less obvious places that you find glass, things like wind turbine blades. A lot of energy generated today is through the ability of glass to translate either wind power through the turning of turbine blades, which are ostensibly made of glass fiber, or through solar cells, photovoltaic cells, I'll say it in its full, that capture sunlight and turn that into electrical energy, which pumps into our grid and allows us to generate green electricity. These are great examples of where it's not normally sort of conceived that glass plays a significant element, but without them, none of that would work. Some slightly more obscure areas, glass fiber goes into sort of monocoques for planes and cars. Things like canoes are fiberglass. All sorts of things are made of a light composite containing glass fiber that brings strength, rigidity, and light for lightness of performance. Slightly more obscure are the understanding that in certain glass types with different compositions, it's possible to create roundabout zero thermal expansion, which means you can warm something up and it doesn't expand. The ability for that to be involved in things like engine blocks to understand precision movement means that in very high performance engines, glass and glass ceramics are very often used as a medium to carry the brunt of being able to exist in high temperatures but perform mechanically in those places. And then looking at some of the even more obscure uses, and maybe slightly glancing into the future here, medical and laboratory instruments, diagnostic equipment in medicine very often uses glass to either split light in the visible, in the infrared, where other materials are incapable, to develop tools for analysis. The ability today to bring instrumentation into play to help us understand the world and medicine, all sorts of problems, is very much premised on the ability of glass to perform as a functional part of many of these pieces of equipment. Without glass, we'd have real difficulty in, well, it would be impossible to make some of these instruments. But some of the even more obscure places, I was lucky enough to work on some of the weird and wonderful elements in glass research 30, 40 years ago. Some of it came to great conclusions, some of it not so. I worked on metallic glasses, which essentially means that if you can condense a liquid metal material at a rapid enough rate, you can stop it forming a crystalline matrix and turn it into a glass. What you do with that glass leaves you with a great palette of possibilities. Some of the things we worked on were metallic glasses cooled at something like 10 million degrees a second by splat quenching, firing molten material onto a cold target into a thin layer. And that material built up can make shafts for golf clubs, which gives them extra resilience and extra flexibility in terms of giving more energy in the whip of a golf club and transport a golf ball further. It helps us understand how we can play tunes in the field of superconductors and insulators. So things like hyperspeed trains can be built on tracks where superconductors are brought into play because of the ability of glass. It's used in simple things like fabrics. People remember fiberglass in curtains and carpets and things, not so much the vogue these days, but certainly a possibility. And these materials are still used in matting for insulation, for houses, for power stations, even in things like the tiles on the front of space shuttles re-entering the orbit to give it that protection from heat. So glass has already a massive range of uses that we don't normally see or understand. So that's just to give you a flavour of those applications. Next slide, please. Just a little bit about how glass is made. Today, it's a pretty much a mechanized process. Mark will come on to show you the possibilities in art to produce handmade glass, which is still a fundamental part of society. But the volume of glass is produced mechanically, large furnaces, independent section machines that can rapidly form molten glass into, as you see there on screen, containers which naturally cool, are annealed to take stress out of them, and then filled with liquids, beverages, things that we consume. These furnaces are very large things. They operate 24 hours a day, 365 days a year, and can last 20 or 30 years these days. So big investments in a stable technology for manufacturing glass as we currently perceive it. The technology used was developed at the early part of the 20th century. There's been a degree of improvement in that, but fundamentally the process in glass manufacture remains pretty much the same. But more interestingly, what do we perceive as coming next? Next slide, please, Mark. Just want to, at this juncture, start to open your minds to how glass can be a material of the future based on almost theoretical physics, without ever going into the complexities and detail of that. But as a scientist, I see theoretical physics being more an art form and an ability to reduce the constraints of the mind. And glass offers us that same palette of possibilities. So conventional chemistry, if anyone studied chemistry at school, you'll recall that we react in whole numbers of atoms forming molecules. So it's either one atom reacts with 1, 2, 3, but it's never 1.753 atoms react with 2.8 of another material. That's because we have these crystalline structures that I mentioned earlier. Glass is not constrained by that. So we don't have to have a regular number of atoms in complement to a regular number of atoms of another material. So we are able to mix and match that palette in glass making in an almost infinite way. So we don't have those restrictions and constraints. And the simplest way of imagining that is you can make a whole palette of colors of glass and a range of hues and shades from just a handful of materials. But if you imagine extending that right across the periodic table at every fraction possible and at every number possible, that gives you such a vast set of opportunities. But I just wanted to run through a rather strange example to help you remove those constraints. So can we have the next slide, please? Here I take the example of what was one of the Arabian Nights tales around the grain of rice on a chessboard. And as a puzzle, our minds would find it really difficult to conceive if you placed a single grain of rice on the first square of a chessboard and doubled that on every successive square until we got to the end. What would that mean in terms of grains of rice on the last square? Can we have the next slide, please? If we extend this theory to say, if we had just 4 chessboards aligned and we put that single grain of rice on the first square in the left-hand corner, bottom, and then successively went across and progressively put double the amount on each square, by the time we got to a square on the top of those, another 8 squares along, we have the number of grains of rice on that single square alone in the top right being 2 to the power 270, which mathematically transpires to 2 times 10 to the 81. And to give you a perspective, there are only, by conventional wisdom, 1 times 10 to the 80 atoms in the entire universe. So something as constrained as 4 chessboards put together, just doubling a grain of rice on each square, would give you more grains of rice on the last square alone than there are atoms in the universe. So if we go on to the next slide, please. If you put that into perspective, allowing for our mind's constraints of what infinity or close to infinity might look like, imagine the periodic table of elements, and every conceivable mixture in every conceivable proportion from that table can be included in glass composition. And therefore the composition possibilities to make things that will solve future problems for society, for health, for science, for economy, for anything that you conceive, is within the power of the ability to make glass across such a vast range of compositional possibilities. Next slide, please. So some of the things I mentioned: frictionless travel, the idea of building computing components that operate at light speed. Currently, conventional computers are constrained by the friction that occurs and the heat generated in silicon materials. But if we can use light speed computing by making light-based computers through the ability to use glass as a medium to move electrons around rather than a physical constraint of a silicon wafer, then we've already demonstrated we can produce chips that can operate at light speed. So the future of computing will be governed by what we can do in glass technology. It will allow things like instant data streaming, so the speed of being able to transfer data will be basically limitless. It will give us a vast palette of medical solutions for diagnosis. We're already using devices. Some of these things, if you're a diabetic, can be implanted just under the skin and give a direct reading of blood glucose levels, and it'll allow an intervention on an ongoing basis without the need for conventional interventions. As I said, in sports and leisure, we've already designed things like golf clubs. It's involved in all manner of research in cycling, in Formula One, in anything to do with electronic and optoelectronic communication. It's also involved in things like warfare, in that the development of things like lasers and LiDAR, which is an extension to laser thinking, which allows the diagnostics of travel through a compromised field, i.e. flying a plane through a smoke field, working a tank through a battlefield where the visibility is practically zero. And we have and continue to work on laser technology for guidance systems, for sighting systems. All of these things are brought about by the ability to vary the palette of glass. It helps us explore the far reaches of the universe, and it helps us explore the areas of the planet that we haven't yet managed to explore, the depths of the oceans and beyond. Every conceivable thing in everyday life is open to the possibilities of what glass can present. Next slide, please. I shall not steal Richard's thunder here, but a mention to what went on at COP26. Glass played a central role in showing what glass can do for the environment by removing carbon from manufacture of all manner of materials made of glass. And next slide. And what Richard will come on and talk about is our investment in the future and how the ability to train the next generation and use glass technology to guide some of the principles that I've talked about and make them a reality rather than a dream is part of what comes next. I think that is me. So I might seamlessly pass on to Richard.
Good morning, everybody. My name is Richard Katz. I'm the Chief Exec of Glass Futures. Now, Glass Futures is a very unique, I know you can't say very and unique, but it is the point I'm trying to make here, completely unique in the world to looking at ways to make glass the most sustainable material, to add to all those wonderful things that Dave has just been talking about. In addition, we want it to be fully sustainable. That means no carbon in the manufacturing process of most glasses. Of course, the most common glasses, which we've been talking about, for instance, glass bottles, glass windows, fiberglass, all manufacturing processes there utilize natural gas, which is high in carbon, as the energy source to melt the materials to form glass. And Glass Futures is a concept fundamentally between Dave Dalton, who's just been talking about it, and myself, to find ways to industrialize new methods of making glass without carbon. Now, glass is, we've just heard, it really is the world's most important material, although Dave would argue about the word material. But it's something which we cannot live without. It's so important to our current generation and probably even more important to future generations. But we're not very good currently at making glass without putting a lot of carbon into the atmosphere. And it's carbon in the atmosphere that is really fundamental to many of the ways of creating what we're seeing here as the catastrophe from climate change. And so Glass Futures was created with a number of different targets in mind, but fundamentally to make glass, to find ways of making glass sustainable without putting tons of carbon into the atmosphere. Therefore, we're in the forefront of the fight against climate change. Glass Futures is fundamentally, we are we've classified ourselves initially as the global center of excellence for glass in research and development, in innovation and training. Now, when we came up with the concept, we didn't quite know how to go about bringing it to reality. And so we started talking to the major glass manufacturers across the world, saying, would you be interested in a pilot plant which can carry out trials which you can't carry out because your production processes are continuous, as we've heard, uninterruptible for 20 years or more, and therefore not easy, in fact almost impossible, to carry out experimentation on those plants. And so the world's major glass manufacturers said, oh yes, what a wonderful opportunity. And cutting a long story short, we have come together with us as a collaboration to create what is today Glass Futures, and centered around a core of a manufacturing plant on a smallish scale. It can produce 30 tons of glass a day, compared with a major bottle manufacturer or flat glass manufacturer who might be making 800 tons of glass a day. But this is scalable. So, and the process which we've developed is designed to be interrupted, designed for experimentation, so it can be replicated. If it works on our kit, it is very, very likely to work on the glass manufacturer's kit. So we're looking at ways to improve mass production methods. We're also looking at ways to train a new cohort of experts in glass, taking us forward. As you might notice, I'm sort of in the last few years of being active in glass, and Dave isn't very much younger than me. We need to find and encourage youth to come into an industry. Um, we, we're looking at alternative energy sources, which might be green hydrogen, which might be gaseous biofuels, might be liquid biofuels, might be electricity, green electricity. Unfortunately, we don't quite have enough green electricity available at the moment for industry. But we're looking at all sorts of different ways. What will work for an industry, and even more importantly, what doesn't work for an industry. Um, Government, regional, national government, has contributed something like £75 million over the last 3 years or so to build the Glass Futures Centre of Excellence. That's 165,000 square foot Centre of Excellence. It's enormous. It's in St Helens, just outside Liverpool, on Merseyside, and the whole essence is to get the glass industry well on the way to being the most sustainable material on top of all those other aspects that Dave has already talked about. And at the end of the day, our aim is really to contribute substantially in the fight against climate change to and I keep on using the word sustainable. We must make certain that glass ticks all the boxes. We are looking to find ways to make glass bottles lighter, stronger, and completely free of carbon. Net zero is a buzzword that we hear all the time. The new incoming government is advocating substantially that we move as quickly as possible as a nation to being net zero. And we want glass not just to be there at the same time as, but we want glass to be there well before others, sorry. Thanks for moving on to the next slide. It very simply outlines what we're trying to do, our disruptive technologies, what works, what doesn't work, and new ideas. And can you go on to the next slide, please? As said, the industry has come together, and this illustrates how the industry has come together. Major glass manufacturers across the world, major brand names across the world because they're part of the supply chain. Equipment manufacturers, Diageo, who makes Johnny Walker, and Guinness, Heineken, ever so well known for beers. The whole collection on an international basis is here under one roof, effectively. And one last slide, please. It's hopefully coming up. A pretty picture of the Glass Futures building in St Helens. And why St Helens? Because St Helens has traditionally been the founding home of Pilkington, which is the creator of float glass and licensing it all the way across the world, what we see as our windows today. At that point, I think I want to prove, and I hope that we are proving, that glass is the world's most important material, and it will remain the most important material. But it's used in all sorts of other areas as well. And so happy to hand over to Mark to talk about his interests in life and where art glass comes
in. Good morning, everyone. I'm not a glass professional at all, but I am a glass enthusiast and a glass collector. And I have the honor to be the patron of three of the most important glass organizations in the art world. And I'll touch on those in a minute. And I'm also a charity trustee of the Glass Sellers Livery Company. So how is glass art made? Well, of course, the most famous thing is blowing. And here's an example of that. You heard from Dave about industrial furnaces. They all have to work at 1200 degrees centigrade or more. So that's an example. This is glass engraving being done by somebody whose art you'll see in a minute. It's called copper wheel engraving. Unfortunately, it's a dying art. We need more people to get involved. This is glass casting. This artist is actually creating a mold in order to cast glass, which is done in a big oven, and you have to let it cool very slowly. So it can be in the oven for anything as many as months. And then this is lamp working, using a small flame on small pieces of glass. In this case, it's glass tubing being used to make neon, but he's also doing a bit of blowing on the end of the tube as well, as you can see. Then there is stained glass, which we've already touched on, and glass beads, also mentioned in the past, and here it's been used as in a fashion show. So who makes glass art? There are about many thousands worldwide. There are more than 1,000 in the UK. That's both professional and amateur. And also in North America, there are more than 5,000. And then there are all the other countries where glass art is produced. And here I've mentioned probably some of the most important and most active as far as glass art is concerned. In the UK, the two main societies which people are members of, the Contemporary Glass Society and the Guild of Glass Engravers. Most people making glass are a member of one or other or both of those. So here are some examples. Here's a simple bowl made by an American, a man and a Swiss lady. Here's a typical piece of Murano. This is factory made rather than handmade. The last piece was hand blown. It's a big plate. Moving on, this is sort of an ornamental vessel made by probably Britain's best or even Europe's best bowl makers. They make fantastic glass in the middle of the North Yorkshire Moor. You can make the glass very small. This, in a way, has sort of harks back to Roman times. And in fact, the earliest glass you can see in the V&A and in the world of glass goes back to before 1000 BC. This is typical molded glass. This is a coronation vase, and was one of the first pieces of glass I ever owned. These are glass baubles. These were given to a virtual carol service that we held during COVID. And the Lord Mayor got one, the current Duke of Edinburgh, because they all read lessons or took part in the service, the Governor of the Bank of England, and Mary Berry and various people like that. And they received this as a thank you. This is a piece of cast check glass. It's about a foot high, I suppose. Weighs when it's very heavy. This is made by probably one of Britain's best glass makers. Again, it's cast, David Reiki. He makes very whimsical and very interesting pieces. This is, you saw the lady engraving glass in the orange goldfish piece in the last set of slides. This is Catherine Coleman, and this represents a sort of architectural piece, and it shows how you can use the glass and the engraving to produce very interesting effects. This is Ronald Pennell, now really retired, but he makes wonderfully amusing pieces. This, of course, is Adam and Eve. You saw neon being made. This is an example. I designed this. I didn't make it, but I designed it during a one-day class, but it shows how you can use neon for art purposes. And finally, there are two pieces that, first of all, this piece has been in Glass Future's atrium. You saw the outside. This is the inside for the past year. It's a big piece and shows that you can make big pieces, and you'll see even a bigger one in a moment. And it's about to move to the world of glass, which I'll touch on in a minute, which is around the corner, also in St. Helens. This possibly is the largest glass installation that's been in Britain for a long time. It was a most wonderful piece. It was hung from the ceiling of Canterbury Cathedral. Fortunately, they were doing repairs on the roof so they could hang it from the scaffolding. It's a 100 glass amphora, which it was to celebrate the end of the First World War in 2018. I tried very hard with Michael Manelli, our Lord Mayor's assistant, in 2021 to have it hung in the city for a bit. Sadly, it just margin didn't come off, but it would have been wonderful had it done so. Anybody knows a home for this, please call me, because they're friends of mine who made it. So where can you see glass art in museums? This is the sort of list. I suppose the best known is the V&A. And actually, when you walk into the V&A, if you look up, there is a huge glass sculpture by Dale Chihuly, possibly from America, possibly the world's best known glass artist. And then there are the world of glass is in St Helens. I always call St Helens the glass capital of the UK. Is a wonderful facility and houses a third of my collection, so I'm biased. But also there's the Turner Glass Museum, the Stourbridge Glass Museum, and the National Glass Centre, which, if you like, are dedicated to glass, while the other museums mentioned have glass, particularly contemporary glass, in their collection. And finally, the Lord Mayor has been going around the world giving glass coins. We made him 1,000. These 4 organizations sponsored it. And he's been giving these glass coins. And I was at a dinner on Wednesday night where he was present, and he gave the clerk of the World Traders one of these in celebration of her service. And he's been giving them to lots of people. So I thought that was a suitable note on which to end. And I think hand back to you, Tim.
Oh, splendid. Thank you very much indeed. When we started off as glass being the world's most important material, I didn't think it was going to range from golf clubs and fire blankets through to all of the other remarkable things that Dave showed us in his final slide. We do have time now for some questions. Following on from what Mark, you were saying, Charles Lamont is asking, how expensive is it to make exotic glasses?
How difficult?
How expensive?
Oh, expensive. Well, I mean, you can buy glass pieces. Perhaps I should perhaps have just said about, you can buy wonderful factory-made pieces, and that's how I started buying, actually going to Scandinavia, and I bought beautiful Costa Boda, the well-known Swedish company, pieces for 20, 30, 40 pounds. But you can get to the exotic prices of 100,000 if you really want to. I would say in Britain, if you want to buy a serious piece, you'd probably be talking at least £5,000, but everything in between.
Goodness. Now, Christine Purdy is asking about the sand available for glass. If it comes especially from the seabed, is this really sustainable?
Maybe I can take that one. There's a lot of conjecture about sources of sand and a lot of misunderstanding about what sand is. Sand that's used for building products is often taken from river banks. There's been a lot in the press over the last 5 or 6 years about that not being sustainable, and there's a great move in the building industry to substitute and find alternatives to that. Glassmaking sand is a very different animal. It is a material often sourced from Belgium, particularly quarries in the UK. But at latest estimates, we have probably about 3 lifetimes of sand for glassmaking available across the world that is not impacting on the environment because of its source and its nature. It's a purer source of silicate material, unlike what you see at the seaside, which is very much bits of animal shells that are ground up and washed. We call it sand. It has a silicate content, but it also has a high calcium and magnesium content because of the nature of it. Glass-making sand is completely different and is currently sustainable for many lifetimes.
Right. Another environmental question. Is there enough renewable electricity if you need to melt all the glass, if you're recycling it, that's needed in the UK? From David Moore.
I know, David, yes. There is enough generation, and we're continuing to invest in that. What is lacking currently, and our discussions with government about provision for this, is the network capacity. If you can imagine, at the moment, our fuel mix in the UK is a mix of natural gas and electricity, ostensibly. So most industrial process have some balance of that. If we were to take the gas away, we would need to up the capability to transmit electricity to all those sites. So it's not the amount of electricity we can generate. The bottleneck, pardon the pun, at the moment is the ability to transport enough electrons down the cables that we have to the remote sites that we have for manufacture. And it's going to take maybe 10 years or more to make the investment in that infrastructure to decarbonise through electricity alone.
Now, Richard Parler raises another environmental question. It's estimated that in North America alone, 1 billion birds a year die through flying into glass buildings. So how can glass be developed in future which doesn't have an adverse impact upon the natural world? Richard Parler.
It already exists.
Dave, I think I'm going to let you answer that one again.
Yeah, it already exists. The issue is around what the construction of the bird's eye, what it sees when it's flying. So obviously, if you've got a highly transmissive glass that has very little or no colour to it, as far as a bird concerned flying directly towards it, there's nothing there and it flies into it. It's quite easy to change the disruptivity of the surface. Imagine binocular lenses. When you look at the reflective properties, they look yellow or red because they have coatings on them that disrupt the sort of macroscopic effect of the surface to interfere with light. We can already put those coatings down and create glass with materials that birds can see. The problem is building glazing is relatively cheap. To add those technologies to it is expensive, and therefore it's not typically done. But it is easily done if you want to achieve it. It comes at a price.
Now, Julia George asking about the wider elements of the glass industry. Given the important uses and infinite potential uses of glass, is there enough investment going into the industry? Which country leads on this? That's Julia George.
Want to go again?
Yeah.
No, there is never enough investment. I think UK is a classic example of that. We tend to be reactive rather than proactive. What Richard explained about glass futures, it was over a decade in the political ambition to move from the concept to the reality. And that typifies the inertia that you have to overcome to gain investment. UK is not the worst. We tend to get leverage of maybe 2 or 3 times where we're performing well. US under things like IRA are performing at 8 to 10 times leverage. So depends how entrepreneurial nations are and what they're prepared to speculate. The UK is by nature a little bit more conservative. In pure research, you've probably got Japan leading in that. In investment, America. In pure technology terms, the UK is way up there. We do invent more than most.
All right. Well, a final plug from Pamela Mounter saying that she hopes that the materials for your wonderful Glass Future Centre are delivered via the Manchester Ship Canal. Now, I was at University of Liverpool for a while, and I think Manchester Ship Canal was some way from St Helens, but it's therefore a good question to end on.
Well, I think, and I'm sorry to disappoint, but I think that might be slightly wishful thinking. Of course, there is a canal in St Helens itself that has traditionally been used to bring in raw materials, but unfortunately it is no longer connected to the rest of the canal network. So I fear we're looking at continuing to come in by road. But of course, we will ensure to the best of our ability that the transport vehicles that are used are environmentally friendly and either driven by electricity, battery in other words, or potentially green hydrogen. We want to set the standard, set the scene at Glass Futures for to be the most environmentally friendly process that we can possibly achieve. And we want to do it in a hurry. We don't want to wait till 2050, 2040. We'd like to be there at 2030 or earlier.
I think as an addendum to that, Richard, to say that already significant glass manufacturers in the region have invested in railheads so that mass transport of material can already occur. And obviously with an electrified rail network and green electricity going into that, we're not complete masters of our own destiny, but more electricity supplied to rail networks allow us to move materials to places like Glass Futures at very little carbon burden.
I leave one thought with everybody, and that's this. Dave mentioned bottle making. I think I'm right in saying, Dave will correct me, 15 million bottles are made in the UK a day, and one factory produces 6 million. That's, I think I'm right.
More than that, we make 2.5 million tons of containers every year, and you get about 4,000 containers to the ton. So you can do the math from there.
Anyway, so that my point is the factory is turning out 60 a second. So next time you drink your bottle of wine, just think about it, because a lot of wine is bottled here. You might be surprised to know.
Goodness me, so it is a massive industry. Now, I'm sorry to all the people who sent in extremely interesting questions, but these are actually passed on to our speakers. But I'm afraid this is all the time we do have for questions. And it's interesting to see that one of the most commonplace of materials is actually one of the most important and elemental to our lives. Just a reminder of forthcoming lectures. Tuesday the 29th of October, sex, delivery in the civic city might have something to do with the gender of past masters, but there we are. Green steel, there we are. We're plugging the environmental issues again, the building block of the future. And we have looked at both the law and history in this series. So we have the early railway age and its influence on the law of England and Wales. Just as a final point, may I say that decarbonisation is a subject dear to the heart of our Lord Mayor Michael Mainelli, and in fact, one of his initiatives is the City Carbon Credit Cancellation Service. If you go online and look up a company called C20, you can find out more about that. So thank you to the audience for your lively interest today. Gentlemen, we've had an extremely good turnout. Thank you, of course, to Mark Holford, Richard Katz and David Dalton, and indeed the worshipful company of Glass Sellers for their sponsorship. Now, this lecture, all our lectures are recorded and posted on the Gresham Society website, on our YouTube channel, in case you'd like to revisit anything, and we hope to see you again soon for another lecture in the Knowledge Miles series. And don't forget the Lord Mayor's theme for the year, which is Connect to Prosper. Thank you, and hope to see you again. Goodbye.